Hi there, welcome back to the part 1 of this course of exploratory data analysis on the Bahmni data. In this part, we shall look at some of the fundamentals required for all the exploratory data exercises that we are going to do before moving on to look at the patient trend across various regions. So as I had mentioned earlier, we should be using the MySQL Workbench client to connect to the MySQL server, which has the Bahmni anonymous database running. So let's quickly move on to that and look at some of the tables and columns of our interest. So if you look at it, I have the local instance of MySQL running. I'll launch it again just in case. So I have set up a local instance of MySQL server running on the 3306 port. So I quickly launch that and open up a query window. And this is the database that we are going to explore. This is the OpenMRS database on top of which Bahmni is built. So some of the data that we are interested is, if you look at it quickly, one is the patient table. In patient table, if you look at it, we have the columns which are the patient ID, which is of our interest. And in each of this table, if you look at it, there is a column by name voided, which means if that particular record has been soft deleted or voided, which is it's not valid anymore. So in most of our queries, when we look at them, we'll have a filter to ensure that we don't pick up the voided records. Along with this patient table, patient extends from another uh, class, or in this case, every patient is a person. So another table of our interest is the person table, which has the person, gender, birth date, and other data. So since we'll be looking at the gender ratio of male versus female, this table is going to be used multiple times. If we closely look at it, we do not have any field which will directly give us the age of the patients, but we have a field which gives us the birth date. So we'll have to do some calculations to calculate the age of the patients. So along with patient, person, we'll also need to look at data from another table, which is person address. This is required because this table contains the data about the region or city or village from which the patient has come to the hospital. So we will be interested in looking at this table as well. As I had mentioned earlier, concept dictionary of OpenMRS is something that we would want to understand. So the other table which would be of close interest to us is related to concepts, which is starting with the concept table in itself. So every observation, or for that matter every lab result, everything is modeled in terms of a concept. So if we quickly look at it, every concept has a class associated to it. So another table of our interest is which gives us the classes of the concepts. So if we were to quickly fire a query to look at all the concept classes, we can see that there are some classes which are of our interest for our exploratory data analysis. Some of those classes are, if we look at it, we would want to look at the top 10 diagnoses. So we would be interested in looking at this. We are also interested in lab results. So if you look at it, there is an concept class by name 26. So concepts created with this particular class and with the diagnosis class are of interest to us. Also, we are also at some point in time going to look at the chief complaints. So and if you look at it, it has it might have a class which is either a symptom, or it might be modeled as miscellaneous. So we'll have to figure out which is the concept class for chief complaints as we move forward. So this concept class table is also of interest to us. The other table which is of interest to us is the concept name. if you look at it, this class is of interest because the name of the lab tests that we are going to fetch for in terms of the observations, the name would be there. We would need to fetch the name from the concept underscore name table. It will be more clear to you once we look at the queries. But I'm just trying to highlight that we will be working with this concept name table as well. Along with that, as we move forward, another table which is of importance to us is the ops table. In this ops table, we will have most of the data related in terms of capturing the diagnosis information, capturing in terms of lab results, everything would be stored. So if we were to quickly look at the schema, there is an ops ID which is the unique identifier for every observation, and this is the person ID. This person would be the patient ID basically. Since every patient is a person, it is being represented as a person ID, and then this is the concept associated to the observation, and this is the encounter. And if it's an result, a lab result, it has an order associated to it. So these are the major important fields. Also, at some point in time, it will be useful if you want to look at particular results over a period of time. The observation date time will be useful to us. And a lot of observations are like uh, values where either it could be a numeric value or a text value. So for tests, lab tests like HbA1c, hemoglobin, the values would be stored in value underscore numeric field. There is also a value complex, but that will not be of much use to us in this exercise. So these are the primary tables which will be of use to us during this exercise. As we move on, when we look at the queries, it will become more clear to us in terms of how we are going to fetch the data by joining different columns across these tables. So that was about the major tables. As we move on, in terms of fundamentals, the other important thing to look at is, as we'll be doing most of our work in R, let me quickly close R and get started again so that it's clear to you guys what do I do in R. So I'll be launching RStudio again, which is the integrated development environment. And I would be giving the GitHub repository link of the code which I have written. So if you look at that code, you will have an R project created. The primary reason of creating this R project is that the working directory is set to the current project directory if we create this R project, or else the working directory is set to a different directory which is configurable. So normally in any statistical work, we may want to read or write some data from the hard disk. So it's useful if automatically the working directory is set to the current directory instead of we having to set it explicitly. Hence, to save some time, I have created this R project file. There are other advantages of creating a R project also over just executing these files, .r files explicitly. But the primary reason in our exercise is that I didn't want to set the working directory explicitly. Hence, this R project has been created. So we'll just click on this R project and say open. So I'll erase all the old data which is there, which is shown in the environment. And this is the console where all the commands executed would be shown. And this is the area where it will show us, it's like a watch window. If you have worked with other IDs, it shows all the current variables in the memory. When you are exiting the RStudio, it can even save this data so that when you launch it back again, all the data which was there previously can be loaded again. That's what I cleared up before a couple of minutes, just to show you that when we start off scratch, there isn't anything in this environment space. In the history place, it shows the historical list of all the R code which has been executed so far. So in case we want to execute any particular R code, again we can just double click or click on that, and that code would get executed. And it also has a Git plugin where it can show us all the Git files which have been checked in and which have been modified. So for our work, I already created an R file, so I'll quickly open that and quickly give you some overview of what I have done so far. So the first slide that you see is the install packages. So normally every library in R, some are base libraries which we don't need to install explicitly. However, all other libraries which we want to use have to be explicitly installed. So install.packages is asking R to install a particular package from an internet source. So this command would require that you have an active internet connection, and after that the library command will load that library into the memory for this particular session. So for every package, first we will do install dot packages and then execute the library command. Now instead of having to do these two steps every time, since we'll be using multiple packages over here, if you look at it from line number 3 to 11, I have used a utility by name install underscore load, which will do two things at a time for us, which would be installing the package from internet as well as doing the uh, library command of loading the particular package into memory. So basically these two steps have been kind of converted into a single step in install load. If the package has been already installed, it will not install again. If it is already loaded, it will not load again. So to reduce some pieces of code, I have used the utility install underscore load, which is available as part of install.load package. Hence, I had to install the install install.load package first, load it into memory, and then use that install underscore load function of the install.load package to then install and load all the other packages. The most important packages that we would be using is the first one, which is the dplyr package, which is primarily used for connecting to the database and then performing all the select and aggregation and all the queries that we would write to fetch the data and summarize the data in R. Stringr package is the package which will contain all the string utilities like string concatenations and string reading and all the string matching kind of function. LibraDate function is for converting string to date, date to string kind of functions will be available in the LibraDate package. Then we will be quickly move on to the RMySQL package, which will allow us to connect to the MySQL database. So it will contain the adapter or the interface to connect to the MySQL database. The readr package gives us functions to read and write CSV files from the hard disk or to the hard disk. The other most important package is the ggplot2, which we'll be using for visualizing some of the data which we would have aggregated in R. The scales package contains functions to scale the data in terms of putting in a continuous format or a percentage format. As we move on in some of the code, you will see that I have used the scales package. LibraDate, this is just a repetition. I have already included it once, hence this is not required. This last one, the EEP tools package, contains the functions to calculate age given a particular date. Hence I used the EEP tools package. The last one is the DBI package. This DBI package is basically a package which gives us the programming interface on top of the MySQL connection. So it gives us a unique database programming interface. It is kind of, it works like a facade on top of different MySQL or any other kind of databases which we may want to connect to. So these are the most important or the top packages that we would be using in our session.